A very good morning, our dear viewers. You are welcome to Homeschool program. This is a program that has been running from the time the quarantine started, and it has been sponsored by our beloved pastors, Pastor Eva Senyonga and Pastor Jackson Senyonga. We are really grateful for this opportunity to allow our learners to continue learning even when they are not at school. Please, parents, we encourage you to subscribe for subscribe for local channels. Top TV will be there, and your students will be able to learn. Okay. Would request my producer to give me slide 5 and emphasize a few things. Slide 5. You can see on top there is the word a must do. Okay. As you come to attend this lesson today, your teacher is Saul Abooki, and I will be taking you through more concept. We started this topic on Monday, and now we have reached at a point of determining the number of moles or masses of different substances. Okay? So what you should be with before we begin this lesson, make sure you have a pen, make sure you have a pencil, make sure you have a calculator, you have a notebook, and please invite a friend to be with you, to attend with you this lesson. If you have a brother who is still sleeping, please tell him to come and sit next to you so that we share knowledge together. Okay? As well, I would like to encourage you to visit our website, that is www.codehighschool.ac.ug, so that you can be able to access these slides. We always upload them, not only these slides of these lessons, but even other topics that have been taught before, or those ones we teach at our school. Please, if you want to get more information, you can visit Code High School. It is found in Seta Bajo, just off Seta Road. When you reach there, go directly to the office of the head teacher. She's a welcoming lady, Madam Tushemeriro Lydia. She will welcome you and tell you what next. Register your student, and your student will be able to study in a good environment. That is it. So let us go to what we are supposed to study. I want us to begin with what we studied yesterday, at least to make a recap of all what we studied. But I want to emphasize a few things. That is the definition. Remember, we are handling a topic called mole concept. And now, every time we look at any subtopic, you have to remember, what are we dealing with? We are dealing with mole concept. And what is it? It is all about determining or counting the number of particles. So that's why I say be with a calculator, because we are going to be calculating numbers. Okay? And it is fun. It is not only academic, but also it is fun. So we also looked at a mole, and we said this is very important, and that's why I'm noting it here. A mole, where we said 1 mole is equal to 6.02 times 10 power 23 particles. Particles. We said every 1 mole is equal to that number. And we said this one is very important. And in every concept we are covering, we're going to find out that we are using this point. Okay? So it is very important. We had this one, and it's where we derived our definition. Because the definition is the amount of particles, okay, equal to this number of particles. Okay? That's what we looked at, and we said we shall be using it. And particles, you can say we have molecules, we have ions, we have atoms, we have protons, we have electrons. Okay? So we also looked at a number of definitions, but for today's lesson, there are definitions which we are going to use. For example, relative atomic mass. I would request for that slide on slide 7, relative atomic mass, and we also looked at relative molecular mass. And when we say relative molar mass, we said is the mass of an atom of a chemical element expressed in atomic mass units, and those are grams. Okay, we said is the mass of an atom. Okay, just the mass of a single atom, that is the relative molar mass. Also looked at what they call relative molecular mass, and we said if we don't say relative molecular mass, we can say relative formula mass, and that one for us we said is the mass of the relative atomic masses of the constituent atom of a mole. Okay, when you have one mole and you have very many atoms in it, for example, we said it might be the mass of a compound. Okay, if a compound, and a compound, remember, is having very many atoms in it. So that's what we are going to be dealing with today. We shall be using those things in our calculations. Also, we had a calculation on the number of moles. Yesterday we were calculating for atoms. Okay, from moles. They could give us moles and we calculate for atoms. Remember here, since you have one mole, for example, 1 mole of sulfur, okay, contains 6.02 times 10 power 23 atoms. So we are substituting saying that particles can be atoms. So if we look at 1 mole of sulfur containing this number of atoms, now you can ask your question that how many atoms can be found in 8 moles of sulfur? 8 moles of sulfur contains, this one we derived it from an easy example that you can go to a market and you say, I need a bucket of oranges. And you know that one bucket is having 7 oranges, okay? So if one bucket is having 7 oranges and you need around 4 buckets, that means you do some calculation. They will ask you how many oranges are found in 4 buckets, okay? So that means it will be easy. You just get, if in 1 there are 7, that means in 4 it will be 7 times 4. And that is the same thing we are going to do here. We are going to say if 1 is containing 6.02 times 10 power 23 atoms, that means 8 moles of sulfur will contain 8 times 6.02 times 10 power 23 atoms. And our answer will be 48.16 times 10 power 23 atoms. Okay? That will be our answer if we are to do that. Okay? So this is what we covered yesterday. Could be given moles and they ask for particles. And we tried to do a number of particles. We looked at atoms, we looked at molecules, we looked at moles, we looked at questions which are general, asking for particles. Then you have to identify which particles are in this question. Okay? So for today, I want us to go straight to our slide 9, and we see what we need to achieve today. As a student outside there, what do you need to achieve in today's lesson? Okay? I want us, before this lesson ends, okay, or by the time this lesson ends, make sure you are able to determine the mass of a substance from a given number of moles. Okay? That is going to be our first objective. We have to first achieve that. We have to first make sure that everybody is able to determine the number, to determine the mass of a substance or of a given substance from a given number of moles. Okay? That's what we are going to cover first. Yes. Then we can also look at determining the number of the mass from a given number of particles. Okay? You can be given mass, moles, and determine mass. You can be given particles and determine mass. Okay? So as well, you can be given mass and you determine particles. That one we did it yesterday in the last example. As well, you can be given mass and you determine moles. We are going to do that today. All right? Let's go on and see what are we going to cover first. We are going to make sure that we first look at how we can convert the number of particles to masses. Okay? We are going to see how we can convert a given number of particles to masses. Okay? Depending on the question. Our topic remains mole concept. And please, I encourage you to stay home and stay safe since you are able to study from there. So this one, I don't want to remove it from the blackboard. 1 mole having 6.02 times 10 power 23 particles. That one is very, very important. Okay? Very important. We should not remove it from the blackboard. So when we are converting the number of particles into moles, okay, what do we need to be with? Okay? We are going to explain that using an example. Okay? We are going to explain that point using an example. And I would request the producer to give us example 1. Everyone can see it. It is calculate the mass of sodium with 1.5 times 10 power 23 sodium particles. Okay? Our example 1, we are going to look at 1.5 times 10 power 22 sodium atoms. Sodium atoms. Okay? That's what we are going to look at first. And this one is going to help us to know how to convert the number of particles into masses. Okay? That's what we are going to look at. Please, I told you that in our first lesson we looked at what they call Avogadro's constant. And we said it is denoted by letter L. If you can look at that example, there is somewhere in brackets, letter L. Okay? There is Na. That means they are giving you the relative atomic mass or relative molar mass of sodium. And you know the symbol for sodium is Na. So you have been given that one. But I told you if it doesn't come in the question, it will come on the last page. You'll find there the periodic table. So you need to go there and see what is in the periodic table and you identify it. The L may come on the first page or may be included in the question. So you have to look at both things. If it is not here, it is the other side. So if you are given a question like this one, how do you attempt to it? Okay? How do you attempt to it? Remember, the first thing you do is to look at this. Say this one is very important. Okay? Say it is 1 mole because that one. And remember, if I come here and write this one, sodium there, I ask you, how many moles of sodium are there? Okay? You definitely say that it is 1. This is 1. Everyone can see it. I don't need to put here 1. Okay? But if there are 2, I need to put here 2. But if there is nothing here, that means it is 1. Okay? That means in every 1 mole, in every 1 mole of a substance. Okay? This means that it is going to be having the mass equal to its relative atomic mass. This one, every 1 mole of a substance is equal to the relative molar mass. And we said relative molar mass is the same as relative atomic mass. Don't need to confuse the two. Okay? If you don't find there the word relative molar mass, you'll find there the word relative atomic mass. It is the same. So once you know that in every 1 mole of a substance, this one is equal to relative molar mass, then you'll be able to calculate this question. Okay? That means if you are given sodium, that means 1 mole of sodium will equal to relative molar mass of sodium. It is given in the brackets as 23. You add there grams. So that is very important. Remember, the question is requiring us to calculate for the mass. Okay? Calculate the mass of sodium. So let us begin from this one, since we said it is very important. Now it is like this. When you are determining particles, what you are determining goes on the right. But when you are not determining them and you are using them, it will go on your left. What you are using goes on your left. What you are determining goes to your right. So since this one is what we are using, we are going to say 6.02 times 10 power 23. What do we say? Are they particles? No. We are dealing with atoms here. It is sodium atoms. Okay? This one, atoms, okay, are contained. We find this number of atoms in 1 mole of sodium. We say that to pass chemistry, there are other subjects which can help you to pass chemistry. So if you find someone doing chemistry, it doesn't mean that that person did chemistry alone, or if you first understood other subjects as well. Okay? Because they also help you. I told you about English, I told you about mathematics and biology. Those subjects will help, and physics in one way or the other. Okay? So once we have this one, now we can go ahead and say, here we have 1 mole of sodium, but do we need are we calculating for moles? No. We are calculating for the mass. That means this one is times 10 power 23 atoms are contained in 1 mole of sodium is what? Those are 23 grams of sodium. You can see how simple it is. Once you have this one, and now you know that this one, the standard figure, is having 23 grams. Okay? So like telling you that in 2 buckets of oranges, we have 10 oranges. Okay? Then they ask you, how many oranges are found in 5 buckets of oranges? Okay? So that means you use simple mathematics. Once they say 1, 2 contain 10 oranges. Okay? Then you say, oh, wait, what about 1? 1 bucket will contain what? That means it will be 10 divided by 2, you get 5 oranges. So once you have what is contained, what is found in 1 bucket like this, you'll be able to calculate for others. If they gave you 2, contains 10, and what about 5? Then you come here and say 5 will contain what? In 1 they have 5, that means here it will be 5 times 5. You get the number of oranges and you find you have 25. Okay? That means for anything that is given, you have to first go back to 1. So that's what is here. If you have 6.02 times 10, power 23 atoms. That means what about in one? Just one atom. One atom is contained in, that means this one will be 23 out of 6.02 times 10 power 23 grams of sodium. You see, here we said two buckets contain 10. What about one? We had to say to get one is just get 10 divided by 2. Now here, to get one, we get 23, you divide by this one. Okay? We are using the same knowledge. Okay? But here, this is the marketing knowledge. This knowledge is from the market. This one is chemistry. Okay? But as well, you can use it. What you know, what you were not knowing, but now I know you have come to know it. It is no longer going to be unique. So what next? You have got 1, and the question was asking for 1.5. Okay? That means you have what is in 1. This means that you can be able to get what is in 1.5. Let us see. 1.5 times 10 power 22 atoms. That means they will be contained in 23 times 1.5 times 10 power 22 divided by 6.02 times 10 power 23. And what you get here will be the grams of sodium. Okay? During this, I don't like putting there dash, dash, dash. Yeah, it is very important to write the words so that you don't get lost. Because if you do this, sometimes you may ask yourself, what is this? Okay? So it is good you put their words. Please, I encourage students, if you know you are a candidate, I know some of you, you reach in exams and you start leaving answers in your head. The head can't be marked. You only submit the paper. So make sure that everything you want to be part of the answer, put it in the paper. Put it on the answer sheet. Don't leave some answer. Don't say that now 6 times 4 is 24. Okay? Now you say 24. Then you leave 6 times 4 in your head. The head will not be submitted. You will submit only the answer sheet. So make sure you put all your answers in the paper so that you'll be able to get all the marks. Remember, those steps count. Okay? So what do we get there? People with calculators, put in your calculators and make sure you get the answer, which is 0.575 grams of sodium. Okay? Hopefully you all have the answer. We can continue with another question, which is example 2. We want to see now how well you can master this. Because one example may not help us to understand. I know some of you now say, I didn't understand that step, but you're going to understand the step which you didn't understand here. In the next example, I'm requesting for example 2 on slide 13, so that my students can be able to understand how to determine the mass from a given number of particles. That is example 2. How many grams of calcium? How many grams of calcium? How many grams of calcium? How many grams of calcium contain 3.0 times 10 power 23 atoms? Okay? If you know you are a chemistry student or you are doing chemistry, hopefully all students in O-level now, they are still doing chemistry. So all of you, I encourage you, please, to make use of the blackboards when you go back to schools. Make sure you use those pieces of chalk to darten the blackboard. Don't play from it. Don't draw cartoons and what. Make sure you calculate numbers. Okay? Or if you are shy, please buy a book, a revision book, and make sure during your free time you are able to calculate some numbers. Because the more numbers you calculate, the more you understand chemistry. Okay? So let us look at our question. It is saying we are looking at 3.0 times 10 power 23 calcium atoms. Okay? These are the calcium atoms. Calcium atoms. We said this one is going to be very important in whatever we are doing. One mole is having this number of particles. But in this question, if you are given particles, that means particles are on the left-hand side, and what they have asked you to calculate for is on the right-hand side, okay? So we bring this one, we just change like this. We say 6.02 times 10 power 23, okay? Now we don't say particles. Remember, the particles are defined here. They are atoms, okay? They are atoms. These ones are contained in 1 mole of calcium. Remember I said when you have this one here and someone asks you how many calcium atoms are there, it is 1. How many moles of calcium are there? There is 1 mole here. Just what is here? You don't need to write 1, okay? That means now if it is 1 mole and in the brackets they have said calcium is equal to 40, okay? And remember, when we are starting this lesson, we said the relative atomic mass or the relative molar mass is equal to the atomic number, is equal to number of particles, okay? The given units in grams, okay? Once you have that, you have calcium equaling to 40. That means that is the atomic mass. Then the atomic mass, what you just need, you need to add there grams to get the relative atomic mass, okay? That is it. So once you have it, you come here and say 6.02 times 10 power 23 atoms are contained in 1 mole of calcium is what? Those are 40 grams of calcium. We don't need moles here. We need grams and number of particles in this question. So that is it. Then we said once you have this figure, what should go into your mind first is getting 1 atom is contained in 40 divided by 6.02 times 10 power 23, okay, grams of calcium. I'd like to also encourage you, please practice out, write well. If you want to pass chemistry, writing well is also very important, okay? Because your answers will be able to mark your answers very fast, not straining themselves with what does this, what is this, what did he mean here. Please make sure you are neat in your work. You'll get all the marks. But I believe all my students are neat, okay? Here, once you have 1, now you go back to the question. You say 3.0 times 10 power 23 atoms are contained in 40 times 3.0 times 10 power 23 out of 6.02 times 10 power 23, and those will be the grams of calcium. Then you get the right answer. Please use your calculators and you give me the right answer. And to give you time, you practice how to use the calculator. Okay, at least instead of playing games, pick your calculator when you are free and play around with it and find out the meaning of different buttons, okay, in your free time, so that you'll be able to master it. What is the right answer? We have 19.93 grams of calcium. Okay, make sure you're able to get that answer. You can see there are a few steps, but you get all the marks. Okay, it is not all about writing a whole book. Okay, that is what they call pouring everything. You just need to select sense from sense, and you'll be able to get all the marks. So we have seen that concept. I would request to go to the producer to give me the next slide, so that we can look at a different concept. We have seen now how we can convert the number of particles into masses. Okay, we have seen that. Now we want to see how to convert masses to moles. Okay, we converted grams into particles. Now we have converted particles into grams. Okay, now we want to see how to convert those masses into moles. Okay, this one is divided into two. Converting masses into grams, converting masses into moles is divided into two. Converting masses into moles. We want to see how to turning masses to moles. Okay? Turning masses to moles. You just need to say 1 mole of a substance will be equal to, now let us see, this one can be divided, it is a substance, that means we are looking at atoms, because this one is divided into two. When you look at atoms, you say 1 mole of a substance will equal to relative molar mass. Okay? In our slide, we have defined that one. You can look at it. You can look at it there. We have said the relative atomic mass, that is RAM, or you can call it relative molar mass, which is RMM. It can be relative molar mass or relative atomic mass. Okay, and we have been able to give you a few examples. Okay, you have 1 mole of copper being represented by 64. You say that one is equal to 64 grams because the relative atomic number is, the relative atomic mass is 64. Just add the G to get the grams. Okay, that number you get it from the periodic table. You go there and you find out the atomic number, the atomic mass of a given element, and you'll be able to bring that answer and you put there grams. Okay, so that's what we are going to be using. So when we go to our very first example, we say calculate the number of moles in 160 grams of sulfur. In our example number 1, it is giving us 160 grams of sulfur. Okay, and in brackets they are saying sulfur equals 32. Okay, if that one is the atomic mass, now what is the relative atomic mass? Okay, that one is the atomic mass or molar mass. Now what is the relative atomic mass? You just need to add there grams and you get the relative atomic mass. Remember I said here it is 1 mole of a substance equaling to grams to relative atomic mass. That means you have been given, this one you can use it straight like this if you have been given moles in the question. But in the question you have been given grams, that means you are going to change this one and say the relative atomic mass is equal to 1 mole of a substance. So here we shall say that for sulfur it is 32 grams. You just put the relative atomic mass straight. This one of sulfur contains 1 mole. Okay, 32 grams of sulfur contains 1 mole. Remember I said once whatever you have on the left hand side, you have to first put it into 1. That means you shall say 1 gram of sulfur contains 1/32 moles. Okay, 1/32 moles. Now we are going to say, what about 160 grams? Okay, if they say that you have 32 oranges in 1 bucket or in 1 sack, okay, now you ask yourself, 1 orange can be found in how many sacks? That means you not be having a full sack, but you be having a portion of that sack. Okay, you just need to say, now I need to divide. If it is 1 sack having 32 oranges, you just divide the sack into portions and be able to get the portion for 1 orange, that the space occupied by just that 1 orange. Okay, so it is the same thing here. If these grams are found in 1 mole, what about 1 gram? You can find it in how many moles? That means you'll be able to divide. Now you go and say, if the number increases now to 160 grams of sulfur, that means this one contains 1 times 160/32 moles. Okay, please use your calculators to get the right answer. Use your calculators to get the right answer. Put in some simple math. During your free time, make sure you play around with your calculators so that you'll be able to perfect them. Okay, so that you stop looking for buttons. You say, now where is 1, where is 2, where is 6? Okay, you'll be able to get 5 moles, okay, of sulfur. That means if 32 grams of sulfur contain 1 mole, that means 160 grams of sulfur will contain 5 moles. You know this one now, the number has increased. Even the moles have to increase. That means any example given on atoms, you can be able to calculate it using this one. Just you need to substitute for these figures. Okay? If you are given calcium, substitute here. Even substitute what has been given here, substitute that word, put their calcium. The steps remain the same. Okay? And you get all the marks without wasting time. Okay, let us see on our slide 18, and we see what we can do to make sure we convert masses to moles, but for molecules. Here we have looked at atoms. Now we want to see molecules. Molecules are the ones having very many atoms in them. Okay? Molecules are the ones having very many atoms in them. So we want to look at least an example from that side. Please, if you have not been able to write some of the things, visit our website, which is www.codehighschool.ac.ug. You'll be able to get these slides. When you reach there, if you don't have the account, sign up, okay, and get a new account and get an account so that you can be able to access the slides. If you have an account already, go there, sign in, and look at what they have posted. You'll find there the slides being posted by Saul, and you'll be able to do personal revision. Okay, now we want to look at molecules. We have looked at an atom. Let us look at molecules. Because an atom is just one, but molecules are containing very many atoms, and we say this one, we shall say 1 mole is equal or equivalent to the relative molecular mass or relative formula mass of a compound, of a given compound. Okay? Remember, on day 1, we calculated for relative molecular mass. We calculated for that one. So today we are not going to waste time calculating for it. We're just going to get the value and continue, because now we see everyone can do that. So we have to do what you can't do. Okay? So when we look at examples on our slides, on our slide there, we can see we have some examples. For example, water. We calculated for water and we said water is having 18 grams. Okay? But I encourage you, when you are given a compound, just calculate. Takes a few minutes and you calculate for the relative molecular mass or relative formula mass. It is the same. Don't confuse the two. We have to look at example 4. Okay? The example 4. At the example on this number. Okay? Let us look at the example. They are saying calculate the number of moles in 4 grams of sodium hydroxide. Calculate the number of moles in 4 grams of sodium hydroxide. We have been given 4 grams of sodium hydroxide. Remember, I told you we are going to start from simple to complex numbers, okay? So at least these ones, I know they may not be simple at start, but as of now, I'm seeing the students who are there, they are enjoying the lesson. That means they are understanding. So continue enjoying and continue understanding, but be able to, yes, if someone missed and you know someone missed, take that opportunity and teach that person. Because once you teach someone, you understand better. Okay? Discuss for someone. If you're there, don't argue over football issues. There is no football going on. Don't argue over movies. Those movies are already there. So make sure you argue over chemistry concepts. Okay? Say, give someone a number, tell him or her to do it. If he fails it, discuss it for that person. Also request for a number from that person, and so that you can challenge each other. Okay? Don't sit home and relax. Okay? So we have been given 4 grams of sodium hydroxide. 4 grams of sodium hydroxide. Now we want to calculate for moles. Remember here we have 1 mole equaling to relative formula mass of a compound. So what do we need to find first? We need to look for relative formula mass of sodium hydroxide. Because you need to know the chemical formula of sodium hydroxide. That is it. Okay? So we have to calculate. We say how many atoms of sodium are there. It is 1. That means that is 23 alone. Plus, how many atoms of oxygen? It is 1. 1 times 16. That means you have 16. Plus, how many atoms of hydrogen? There is 1. 1 times 1, get 1. Then, when you add up, you get 40 grams of sodium hydroxide. And that one will appear to be the relative formula mass. We said the relative formula mass is the relative molecular mass. I keep emphasizing those things so that I can help you not to confuse the two when it comes to exams. And please also keep practicing. You have got that one, and we said here, 1 mole equals that one. 1 mole equals that one. Grams. That means what we look at the question. If we have been given moles, that means we are going to calculate for grams. But if we have been given grams, we are going to calculate for moles. And what we are calculating for goes on your right, and what you have been given goes to your left. So here we shall say this one will change and rate it first. Then we put moles last. We say now there are 40, according to the relative formula mass, there are 40 grams of sodium hydroxide. Okay? We say these ones contain 1 mole. Sure. Okay? 40 grams contain 1 mole. What next? We said anything that is on the left-hand side, you have to put it into 1 gram. 1 gram of sodium hydroxide, we shall say that contains 1 out of 40. Okay? And we say these ones are grams of, we say those ones are grams. Okay? That means 1 gram. Sorry, these ones are moles. On the right hand side, we have moles. Okay? That means in 1 gram, we have those number of moles. Then what next? We look for 4. What about 4 grams of sodium hydroxide? That means this one contains 1 times 4 out of 40 moles. What will be our answer? Please put that one into the calculator and you get the right answer. All right? Put that one into the calculator and get the right answer. I told you during the free time, make sure you play around with the calculator, so that that one should not be a problem. By the time you leave home, be able to use the calculator even when you're not looking at it. Okay? You know where everything is. That is a student. That means we shall not waste time teaching how to use a calculator. Where is 1? Where is 2? Where is fx? Okay? Where is a? Be able to get those things on the calculator. Okay? When you put that one into the calculator, what do you get? You get 0.1 moles. Is it okay? 0.1 moles. In summary, once you have got that one, in summary, I'm requesting for slide 21. In summary, want to see how we can be able to calculate these things. Because now I've been looking at all these steps. Okay? I know you have understood them. Okay? But now we want to look at the summary part of it. How we can summarize them. We see that converting masses to moles, we look at that summary. We say that if they have asked for the number of moles, you say given mass over relative atomic mass, that is for atoms. And we define that one. Relative atomic mass means RAM means the relative atomic mass. And we have the definition in our books. Then We also look at number of moles. For molecules, we say given mass over relative molecular mass. Okay? That one is evidenced here. Let us turn to our blackboard and see that one. Okay? They have said that given mass over relative formula mass. It is here. It is just 4 over 40. And 4 is the given mass. And if this 40 is the relative formula mass, you see, it is there on the blackboard. And that's what we are seeing in our summary. Okay? So once we have that summary, then we are going to be able to calculate several numbers. And that's why I have come up with an exercise. Okay? Let us go to the exercise and see how the exercise is looking like. I want you to be ready. You copy the exercise. For those who can access us, you make sure you talk to us either on our website, or you can send a comment on Top TV, television, Facebook page. Drop their comment, because all these videos are there. Drop their comment, please. I'm requesting for the exercise. Let it be displayed on slide 22. Put the exercise on slide 22. Please attempt to the exercise and make sure you be able to answer all those numbers. Parents, encourage you to monitor your students, your children. Make sure you check, even if you don't get some of the things, but see if someone can be able to raise something. That means he or she has involved himself in the work. So at least we don't aim at getting the correct answers. We aim at least trying out, because we know once you try out, you can be able to get something at the end. But once you don't try out, then things will not be next to you. You always cry. I would request the producer to first allow the students to copy the exercise. I know in that exercise you have been given the different elements. Okay? Make sure you copy them. If you don't have them, I know some of you have periodic tables. Go to your periodic tables and copy those things. All right? So that you'll be able to answer the exercise very well. I would request the producer to go to the very last slide. Please, objective, go back and check. Have we been able to achieve the objectives? Are we able to calculate the given masses? Are we able to convert masses into moles? Are we able to convert particles into masses? Let us go to the last slide. Very last slide. Okay. On that very last slide, we have what we are saying. This is the day. This is the time. May I stand with my brother Solomon to say happy birthday to our director, Pastor Eva Senyunga. We wish you a nice day. Please, I've been Saul Chamanywa, who has been taking you through chemistry, O-level, and I request you to continue following us on Facebook, Top TV page, or on our www.kodaischool.ac.ug website. You'll be able to get everything. Thank you. Stay connected with us.